All right, so we're going to start section 1.4 with our foldable. At the top, it talks about a polygon. The definition of a polygon is it's a closed figure formed by 3 or more sides. What it means to be a closed figure is that the sides must all end up touching each other. So like this is an open figure, so this is not a polygon. And then the sides, when they're talking about sides, they're indicating straight sides. They can't be curved, so polygon is no curves. And they have to connect to each vertices. So like you can't have something like this where the side extends farther. So that's, that is an extended side. If you didn't have that piece, then that's definitely a polygon. So they need to connect to the ends of each side. It's not just somewhere wacky in the middle. Okay, so how you name a polygon is you just list the vertices in order. So like if I started with vertices E, I'm going to go around the figure. So I'm going to do E, all uppercase, F, G, H, I, and then J. So I would name it with all vertices in order. So what I can't do is I can't just jump across and be like E, then G, then H, jump across to J, I, and F. It does not work like that, so don't do that. Go in consecutive order, all uppercase letters. All right, so classifying a polygon by the number of sides. Let's talk about the ones you know. So a polygon with 3 sides is called a triangle. Now a polygon with 4 sides, many times in class people say square or rectangle. Those are 4-sided polygons, but we need it to work for all 4 sides, not just a specific polygon. So we're going to do quadrilateral. So any 4-sided polygon is called a quadrilateral. So a 5-sided polygon, how I remember that is thinking about the building in Washington, D.C. that has 5 sides. So that is a pentagon. 6 sides is a hexagon. And I don't know, it just in my head sticks out if I remember that 6 has an X and hex has an X. It just helps me remember they go with each other. 7 is like the most difficult for all students to remember. I don't really have a trick other than just memorizing it. It is a heptagon. 8 is pretty easy for all of us, octagon, just like a stop sign. Now 9, I'm not sure you know, 9 is a nonagon. 10 is easy for me to remember because 10 years is a decade, so a 10-sided figure is a decagon. Now there is a very specific name for an 11-sided figure, but we don't memorize it in high school. It's really not needed. We actually, weirdly enough, just call it an 11gon. But then on 12, we go back to having an official name. So 12 is 2 years past a decagon, so it is called a dodecagon. And for me in my head, it makes me think of dos, like 2 in Spanish. So I have a dodecagon, it's a decagon plus 2. Now 13, we go back to 13gon. And everything after that, there are specific names, but we don't memorize them. So we have a 14gon, a 15gon, a 16gon. So n just represents any number of sides after 13. So however many sides, you do n-gon. So like if it's 55 sides, you would call it a 55gon. So that's just an example there. All right, and then at the bottom for foldable, we have a convex polygon and a concave polygon. I'm going to start with concave. So what's awesome about concave, it's really easy to remember. It caves in. So I'm going to draw it and try to make my sides straight. Doesn't matter how many sides it has, but you guys see right there, it caves in, and so that's a concave polygon. Now a convex polygon is not going to cave in. So the specific number of sides don't matter, it just matters that it doesn't have a cave in it. There are more fancy definitions for that, but you'll just be required to be able to look at a polygon and determine if it's convex or concave. So I think kind of the basic works better than like a formal fancy definition. All right, so on your 1.4 notes, we're not necessarily going to go over all of these because we've used a foldable, so we don't have to fill it all in. We have a lot of information on our foldable that we can have in our interactive student notebook. So let's jump down 1.4 notes, example 1. So on 1A, it says, classify each polygon by the number of sides. Well, so just count them. I'm just going to mark them. That's 1, 2, 3, 4. So this is 4 sides. So if you look back to your chart, this is a 4-sided polygon, so therefore it is a quadrilateral. Now notice right here it caves in, so it says tell whether it's convex or concave, and it is concave. All right, so on B, I like to number them so I don't overcount them. So 1, 2, 3, 4, 5, 6, 7. So it's a 7-sided figure. You can look back at your chart. That's a heptagon, and it does not cave in, so it's convex. All right, you guys go ahead and try C. I'm going to ask you 2 questions in Edpuzzle. I'm going to want to know classifying by the number of sides and tell if it is convex or concave. All right, so 1, 2, 3, 4, 5. 5 sides, so it's a pentagon. And it caves in, so it is concave. Go ahead and do the same thing on example 1D. Classify by the number of sides, and then I'm going to ask you a second question saying, is it convex or concave? All right, so here, 1, 2, 3, 4, 5, 6. So it's 6 sides. That's a hexagon. And it is convex. It does not cave in. All right, so on the back side of your notes, example 2A, I don't think we need to go over all of this. We're going to do a lot of practice today and tomorrow on it. So let's just do one to get the basics, and then we'll go from there. So it wants us to find the perimeter and the area of this triangle. So I went ahead and put the dots on here just to try to help make your notes go a little faster. So if you just want to go ahead and draw in the sides. So perimeter is where you just add up all the sides. So like this side down here, C to B is 1, 2, 3, 4, 5 squares. So it's 5 units. So CB is 5. AC is the left side. It is 1, 2, 3, 4, 5, 6 units. Now, I don't know how long AB is. That's the hypotenuse. I don't know how long that is. So what I need to do is I need to find that using the distance formula, which we did in 1.3, and it would be in your interactive student notebook in terms of the formula if you do not remember it. So you can set up the distance formula using the points. So, for example, if we're doing AB, A is at -2, 3, and B is at 3, -3. So I would just determine which one's x1, which one's y1, and which one's x2 and which one's y2. All right, so I'd have -2 minus 3, that's -5. Squared is 25. And then 3 minus -3, that turns into plus because minus and negative is plus. So I have 6 squared. Oops, sorry. So I would have 6 squared, which is 36. All right, so now 25 plus 36 is, sorry to think about that, 61. So that distance would be the square root of 61. Now, it's going to be a lot easier just to go ahead and to type it in your calculator and then use a decimal as we calculate this. So I got 7.8 roughly. So AB is 7.8. So the perimeter of the triangle, you add up all the sides, 5 plus 6 plus 7.8, and you get 18.8 units. So basically, perimeter is add up all the sides, and if there's a side that's not straight vertical or horizontal, then you need to use the distance formula. You could also use the Pythagorean theorem like we learned back in section 1.3. So then the area, because it's a triangle, the area of a triangle is 1/2 base times height. So your base and your height have to be at a right angle to each other. So it's really convenient that this is a right triangle because your base and your height can be these two sides right here, and they are at a right angle to each other. So what your formula can be is, let me change my color here, 1/2, the base is 5, the height is 6. 5 times 6 is 30, and half of 30 is 15. So it's 15 units squared, or 15 square units. And that's our answer.